In example 6, we're finding the composite surface area of this cylinder sitting on top of a rectangular prism or a box. And there are a couple ways to approach the breakdown of this composite surface area. Um, we could find both surface areas totally separately, full surface area of the box, full surface area of the cylinder, but then we have to be very careful about subtracting away surfaces that are not exposed on the outside. Um, some students like that approach. Personally, I don't. I don't like to add things in and go through that extra work just to then do additional extra work to subtract them away. So, my recommendation here is let's carefully think about what we are adding together. With this box, we have most of everything exposed except for the little circular part where this cylinder is sitting on top. For the cylinder, obviously that bottom base of the cylinder is covered. It's trapped in the inside, so it's not exposed. But that top base is on the surface. What I like to do is I like to think about that top circular base of the cylinder. Think of it being pushed down through to cover up that part of the box that is missing and covered by the cylinder. Okay? It's like that we have the full surface area of the box, but that circular part, we're just including that from the top base of the cylinder. So to work this out with the equations, I like to think of this composite surface area as the surface area of the complete box, plus, for the cylinder, we don't have to worry about the bases, right? The bottom base is trapped in the inside, so that's not exposed. We already considered that top circular base as covering the circular part of the box that was missing, so that only leaves us with the lateral area of the cylinder that we need to add on. So if we take this approach, I think it really simplifies what we are calculating and allows us to get to the final answer in a fairly efficient manner. So for the surface area of the box, I'm going to use our special equation for a right rectangular prism, which is 2 times all combinations of length, width, and height. So 2 times the length and the width, let's say 2 times 9 times 4. We'll take care of the bottom and the top bases. Add on to that 2 times 4 times 5. That will take care of the right and the left sides. And then our last combination would be 2 times 9 times 5. That would take care of the front and the back faces. And then to this, we're going to add on the area of the lateral area of the cylinder. So lateral area of the cylinder, we know lateral area would be circumference of the base times the height. The circumference in this case would be 2 pi r. So 2 times pi. We have a radius of 2. And the height is 3 centimeters. Okay. So let's just take care of that part while we're here. 3 times 2 is 6. Times 2 is 12, so we have 12 pi. And we do know that our final answer, we want to round to the nearest tenth, but for right now, let's just leave that alone, leave that in terms of pi. For our rectangular prism or our box surface area, really you could just carefully type this all into your calculator. No need to work that out by hand. I mean, you could simplify each of those by hand. They're pretty easy numbers to multiply, but just be careful that you're keeping track of everything. So you multiply and add these values together. We get a surface area for the box of 202. And then we're going to add these together. Now this is where you need to get a decimal value for pi. So we'll do 202 plus 12 times pi. If you type it into your calculator like that, it should acknowledge the order of operations for you. And rounded to the nearest tenth, we get an answer of 239.7 square centimeters.